So today I'm going to show two quick techniques for creating threads on designs for 3D printing. So let's start with a circle. I'm going to create a sketch on the top plane, and I'm going to make a circle in this example that's going to be 5 millimeters. And then the height is going to be 10. So I'm going to start with a cylinder, um, and this is going to be the base of the threads, and then I'm going to create the nut or the piece that gets threaded onto it. So let's create a sketch on top of the cylinder, and I'm going to make a polygon that's a hexagon. So I'm going to go to polygon, circumscribe polygon, and I'm going to use the center point to create a hexagon. But I'm going to want to extend this a little bit further. So to make it a little bit more precise, what I'm going to do is create a line from the center of the circle to the edge, and then go another 1.5 millimeters, and that's going to be where my hexagon is going to extend until. So let's go to create, polygon, circumscribe polygon, center of the circle to the edge, and that should be good. So I'm going to hit finish sketch, and then I'm going to extrude this hexagon that I made upwards. I'm going to go 3 millimeters, and I'm going to hit OK. So now we have the nut and the base that we're going to thread together. So let's go to create, and let's go to thread, and then I'm going to select the outside of the cylinder, and you can see the thread design appears. But if we wanted to actually 3D print, we're going to have to check modeled. And I think this happens because for Fusion 360, in order to save memory to make it run quicker, it doesn't by default show it. So in order to 3D print, we have to click on modeled. You can see it's an M5 by 0.8 screw or thread. Because it's 5, we made a circle that's 5 millimeters. There's a lot of different, we're using metric profiles, ISO metric. There's a lot of different ones based on your needs, but we're going to stick to the ISO metric. And all the other settings look okay, so I'm going to hit OK. And that will apply the threads. And I'm going to do the same thing to the inside part of the nut. Let's go to create, thread. Check modeled again, and it should be the same designation, M5 by 0.8. That'll ensure that they're designed to come together. So let's hit OK. So there's the two pieces that are going to get screwed onto each other. But let's look at a section analysis to see how they actually come together. We'll go to inspect, section analysis, and what it's going to do is create a cross section of whatever we want in order to get an inside, so to speak, look at it. So I'm going to click on this plane, and you can see what it looks like on the inside. Let's hit OK. I can turn off section analysis as I want as well, but it's a useful feature to really look at your designs from the inside. So what I'm going to want to do is to take the nut part, which is body 2, and I'm just going to move it down to see how well it aligns with the threads. Perhaps maybe something like this. I'm going to hit OK, and you could see that there's a little bit of a clearance. I think by default Fusion 360 gives you 0.1 millimeter clearance, which if you have a very precise 3D printer, it might come together. I've never had personally much luck with this. So what I do is I can scale one of the pieces to make it smaller in order to make sure that they actually are able to thread onto each other. Otherwise, from my past experiences, they're not able to come together because of the tolerances of the 3D printer. So let's scale either the outside piece, the nut, bigger or scale the inside piece smaller. And that's what I'm going to do. I'm going to scale the inside piece a little bit smaller. That's body 1. Let me turn off analysis for this, and I'll take body 1, I'll go to modify and scale, and I just want to use a little bit of a smaller scale factor. So 1 is full size. I'm going to scale it down by about 3%, so I'm going to use 0.97, and I'm going to hit OK. Let me turn analysis back on, and I'll see if I can arrange it again in order to see how it fits. So I'll put my axes. Let's go to good view. I'm just trying to arrange it so I can move it correctly. Perhaps something like this. What this should do is give me a little bit of clearance, a little bit more clearance to make sure the piece is able to thread correctly. So this, of course, also depends on how big of a piece. If you're making a very big piece that gets threaded, you might need to scale it a little bit less. So instead of 0.97, you might do 0.98. Whereas if you're doing something small, you might have to scale it a little bit better. So it's important to be able to test print. The other thing to be aware of is scaling something scales just that one piece relative to each other. So there's a chance that it might not align anymore after scaling. I've had a lot of success using this strategy. But also sometimes if you are making a design that is not a simple nut and screw, for example, this lantern design threads the base onto the main part of it, and I likely wouldn't want to scale either parts in order to adjust. I'm just going to want to make sure the threads fit in their own right. So that's where the second technique could be useful. So I'm going to just turn analysis back off, and this is the design that I had from the previous one before scaling. Let me go back to my section analysis, and I'm going to hit OK. Let me align it, and then I'll show you the other technique that you can use. And take component 1, and I'm just going to move it to get a decent alignment with the threads, something like that. Hit OK. The other technique is to offset the inner threads, to offset the threads of the screw. So in order to do that, let me turn analysis off. It's under modify and offset face, and I'm going to take the top part of the threads, this part right here. Let's click on it, and since Fusion 360 by default gives you 0.1 millimeters, I'm going to do another 0.1 millimeters, so it's going to be offset by 0.2 instead of 0.1. So, and I also want to make it smaller, so it's going to be negative 0.1, and you can see that the faces are brought together, so to speak, a little bit more. So I'm going to hit OK, and let's turn analysis back on, and you can kind of see that it aligns well, and you can see that there's also more clearance there. So that's another useful technique when designing threads. At the same time, there's a drawback to this. If you look at the sharp edges now that we created by offsetting, it has a tendency to sometimes degrade the threads because you're working with softer plastic when you 3D print. So it might be useful to give it a little bit of structural integrity if you use this technique, and that's a pretty easy thing to do if you fillet. If you fillet these corners away, and then you'll have to fillet the nut part or the other part that screws on as well. So let me show you how to do that. We're going to go to modify, and we're going to go to fillet. Let me turn again section analysis off, and what I want to fillet is that sharp corner, and I'm just going to use something pretty small. 0.15. Between 0.15 and 0.2, I think is enough for you to round it off, but at the same time, not overdo it and have a noticeable difference in terms of the working, in terms of it actually coming together the way you want it to do. So 0.15 will be okay. So under analysis, you can see that it's rounded off the corners, but we should probably match the outer threads to this as well. So let's do that. I'm going to go back to fillet, and I want to select two parts of the inner threads. I'm going to select, well, let me turn off component 2, and I'm going to select this part. I'm going to hit Control and select that part as well, and it's going to select the entire length of the threads, which is what I want. And I'm going to match the fillet from the inner thread. So I'm going to go 0.15, let it do its thing, and let's hit OK. So as you can see, what we've done is we also filleted the outer piece to match. Let's turn on component 1, and I think that looks good for a test print. The big variable is the size, so it's important to be able to test print it to see how it comes together in real life. But those are two easy techniques for designing threads in Fusion 360.